this video, we will solve GATE 2022 MA Set 1 question number 36. This question is from the topic Engineering Mathematics and from complex variables. The question is the value of the integral given by this relation evaluated over a counterclockwise circular contour in the complex plane enclosing only the pole z is equal to I, where I is the imaginary unit is. And these are the four options. Now let's see the theory we need to solve this question. So we need to know the residue theorem, and the residue theorem states that if f of c is an analytic function on a closed curve C except at finite number of singular points within C, then the contour integral f of c dz is equal to 2 pi I times the sum of residue at the singular points, and these residues are calculated by this expression. So the residue at a simple pole z is equal to a is given by this formula, that is residue at f of a is nothing but the limit z tending to a, z minus a times f of z. So we will evaluate this limit in order to get the residue at this point, which is a simple pole. Now let's try to solve this question. So we have to evaluate this integral 6z over 2z power 4 minus 3z cube plus 7z square minus 3z plus 5 dz. And we have just seen from the last slide that we can use the residue theorem to say that this will be equal to 2 pi I times the residue at z is equal to I. So that is because here it has been given in the question that this plane encloses only one pole at z is equal to I. So now calculating the residue at z is equal to I, again from the last slide, we can say that this will be equal to limit z tending to I, z minus I times f of z, where f of z is this. So that is nothing but limit z tending to I, z minus I times 6z over 2z to the 4 minus 3z cube plus 7z square minus 3z plus 5. Now if we substitute z is equal to I in the numerator and the denominator, we can see that this becomes the 0 by 0 form. So this becomes a 0 by 0 form, and thus we can use the L'Hopital's rule and say that this limit will be equal to limit z tending to I. So this limit will be equal to just the derivative of the numerator divided by the derivative of the denominator, which will be equal to 12z minus 6I over 8z cube minus 9z square plus 14z minus 3. And now we can substitute for z equal to I, then this becomes 12I minus 6I over 8I cube minus 9I square plus 14I minus 3. Now this will be, so the residue at z is equal to I will be equal to 12I minus 6I, that is 6I in the numerator, upon 8I cube will be just minus 8I, and this will be plus 9 plus 14I minus 3. So this is just 6I over 6I plus 6, or I over I plus 1. Now we can substitute this in this expression 1 and say that our whole integral, the contouring integral of f of c dz, will simply be 2 pi I times I over I plus 1. Now we can rationalize this expression and say that this will be equal to 2 pi I square times I minus 1 over I square minus 1. So the denominator becomes minus 2, and then this 2 from the numerator gets cancelled, and this simply becomes pi times I minus 1. Or we can say that this will be equal to minus 1 plus I times pi, and that is the option A. So the correct answer to this problem is option A, minus 1 plus I times pi. And in order to know more about the residue theorem, you can refer to this NPTEL course video on calculus of residues by Professor V. Balakrishnan of IIT Madras.